Well, good afternoon. I'll make this brief so we can get on to the Sea World while they load up the slides. So what I'm going to talk about is the Internet of Things for the upstream oil and gas people, and value. And the value is increased production, lower operating costs, and improved safety. So obviously, besides the current price challenge that the oil and gas is up, there's a number of challenges that the upstream onshore oil and gas industry is facing. One of which is a large area of operation. These fields now, especially with the unconventionals, are huge. They can be 20 miles by 60 miles in size. They're larger than some of the US states. Also, with the downsize of price, the drilling and completion activity has really dropped off. That means that they've entered in from an exploration phase to really an enhanced recovery phase. So they're trying to get more out of the existing wells rather than trying to drill new wells right now. So it's very important to get that. Another challenge they have is the advent of smart sensors. It's really sort of outstripping the capacity of their existing SCADA stuff. We also have, like everyone in the oil and gas business, a real shortage of skilled workers, especially in the automation area. The other thing that we're seeing is that the OEMs are now shipping with embedded systems. So you're seeing things where they're optimizing things like pump jacks and things like that. Compressor health, things like that. But also, we're seeing that there's a lot of shareholder activism, meaning that the shareholders now are demanding better rate of returns that they've invested during the boom times, and now there's a large pressure on CapEx to really get that rate of return accelerated. So what that means is the field automation had to respond to those changes, and they did that by doing three major things. Number one, they reduced operations costs. They did that by moving to what's called management by exception. With remote well monitoring, you're no longer doing routes where you're sending somebody out to the well to monitor the condition of that site. When they make a trip to the well site, it's a task specific trip because they already know the condition of that. So they're going out for a specific mission, just not to get readings. That reduces the amount of driving, it reduces the amount of people that you need in the field. That results in less operational costs. The second thing is the increased production. And what that does is by field automation going and giving better visibility into these brownfields, what you can do is make better decisions on things like infield drilling and well interventions, things like artificial lift or chemical treatment, those kinds of things. Also, you can get increased production by reducing unplanned outages, so things like compressors, engines, things like that. So you really want to optimize your uptime. Also the third thing is the production chemical treatment. You want to make sure that so in this business you inject chemicals, things like for H2S mitigation, anti-foaming, anti-drag agents, things like that. You want to make two things are happening. Number one, you want to ensure that your dosing rate is correct, and right now that's a very manual process. The second thing that you want to do is make sure that you don't run out of stock, because what that can occur is if you run out of chemicals at the well site, you have to shut in until you get those chemicals back on, because like for example, if you're injecting anti-corrosion, that you don't want to do damage to the rest of your plant by not having that mitigation. And then lastly, the improved safety, they had to respond to that by, again, the remote monitoring means that you can basically do significantly less driving. On average, there's a major incident every 100,000 miles. The leading cause of death for the oil and gas industry is driving. So there's a huge amount of risk that you can take out of the system by using field automation. One of the interesting aspects of moving from a greenfield to a brownfield type thing, there's two major priorities that have really changed in the oil and gas industry. Number one, asset integrity has become a very high priority. In other words, you want to ensure the long-term performance of your field. You want to make sure that equipment doesn't burn up. You want to make sure that it's being run at an optimum rate. The second thing is you really are very concerned over well integrity issues, so leaking casing or other sorts of issues like that. So you really want to capture things like corrosion, equipment health, and things like that. Again, just to make the most of what you have. The second thing is to increase what the industry calls estimated ultimate recovery. And what that is you're just squeezing more oil out of your existing field. So you're not drilling as much anymore. So what you want to do is go into enhanced recovery there. Unfortunately, those kinds of techniques, what you will need is additional monitoring to confirm the performance of those kinds of interventions. Another thing that the industry's faced on is a tidal wave of new data. There's many new wells. The reason the new wells have been brought on is that in a lot of the unconventionals, they go into a rapid decline curve, and after 18 months, they're significantly only maybe 10% of the initial flow rate. So the way to do that is they've had to drill a lot of wells in order to increase the kind of production. The other compounding factor is each of these wells are now generating significantly more data. So you have smart conventional sensors that have 20 or 30 secondary values being generated. You're also having things like waveforms for acoustics and vibration. But you're also seeing distributed computing where things like in the SAG-D and things like that in northern Canada, they're using fiber optic cable as a sensor, and they're capturing things like acoustics and temperature in order to understand reservoir properties. So some of these well sites can generate about a terabyte a day of data. So there's a whole tidal wave of new data. What that means is that we've outstripped our ability, and in order to meet these kinds of challenges, we need a whole new approach. So moving away from the sort of the SCADA-centric systems to a very enterprise-based system. And that allows you to then get around a lot of those issues. So this is what I mean. On the right is the traditional SCADA ISA 99 Purdue model type thing. Your field devices go into your process control network. Your process control network goes into a shared zone. The shared zone goes into your corporate network, and your corporate network goes into the third-party sites. So the problem with that is if a person puts an embedded system and it has 50 embedded devices in that compressor, then it has to go up all those layers and all the replication cost and complexity. Also, if the customer is a corrosion engineer at the corporate office, again, you have a lot of cost and complexity that is routed through a system that was designed for closed loop control. So it's a very expensive way to do that. On the left is the alternative to that, and that is that the data goes from the wellhead directly to the enterprise. You use things like subscription services, so you're pushing things rather than polling things, so you do away with the polling algorithms. You also ensure edge-to-edge encryption, things like that, so you're inherently just more secure. And then you push the data back into, this is typically monitoring data and not control data. You're pushing stuff back into the SCADA system for the operators. You're pushing it to the corporate headquarters. You're also pushing it to third-party sites, but also you're pushing it to mobile devices. So this way, you sort it out in the cloud, and you don't present threats to your process control network where suddenly it becomes a conduit and the firewall starts to look like Swiss cheese and things like that. So you really mitigate a lot of the risks associated with answering these challenges. So the benefits are you ensure an end-to-end solution. You make sure the data gets from the wellhead to the intended users, and it doesn't get stuck somewhere in a shared zone or on a SCADA system. It also, because you're using shared infrastructure for things like backhaul, you don't have to build out a private network. You can shorten the time to first oil, because now you have a lot less build out. It also scales much better because, again, you're using shared infrastructure rather than having to build out private. It improves safety because you're doing significantly less driving. You're supporting the new wave of data, so that the multi-flow phase flow meters and gas detection and things like that are now readily, it can support that because you don't have to redesign your SCADA to support that. It also, it's really very compatible with the new workforce, because now they're getting readings on tablets rather than on conventional SCADA systems. Sweet spots: annulus pressures, production chemical management, corrosion monitoring, critical health, equipment health monitoring, gas monitoring definitely, and then the embedded systems that the various equipment manufacturers are sending out. So, bottom line is, we can significantly improve production, lower operating costs, improve safety. However, to achieve those, we need to take a significantly different approach to how we get that data out of the wellhead. Thank you.